material to cover, and I only have 1 hour because last time I talked for too long. So in order to give you more time for the exercises, I'm going to go a little bit quickly now. Maybe you won't have the time to exactly type in every command I'm showing you, but you will have the slides. You already have them actually, and so it doesn't matter. You can exercise afterwards.
Can I talk?
Yeah, look, it's better. And still, if you have questions, please raise your hand. We do definitely have time for questions. Yeah. If you don't understand certain things.
What does that mean? Yeah, exactly.
What does that mean?
What does that mean?
What does it mean?
Where is Amir?
Amir is coming. He's still finishing the exercises. I hope. So, just a quick summary of things we covered last time. So how can you see where your current folder is? Well, you can type pwd, present working directory, for example, and you can change your directory with cd in the command window, or you just go on top, where you have basically your path, and you can modify it in a user-friendly way. How do you create a variable? You just say the name of the variable equals and assign something to it. That's how you create a variable. Remember that if you create a variable which is capital letters, you need to call it with capital letters because Matlab is case sensitive. Also remember that you cannot use spaces in variable names and that the variable name can not start with a number. Okay, how do you clear? Well, you can say clear all or clear space and then the name of the variable you want to get rid of. You can, and later on you will have to use the semicolon to suppress the echoing in the command window. So if you type x equals 1 semicolon, nothing happens. It will create x, but it will not show you the output. How do you get help? Well, you can type help. Sorry, that's actually, I think, shouldn't be capitalized. And then space and the command name. If you want to get the nice interaction window, then you say, instead of help, you say doc space and then the command name. For example, doc space me. Okay, so data is stored in arrays, and we have elements, and we have vectors, which are basically just elements arranged in one column or one line. You have matrices, which are two-dimensional or three-dimensional. But remember that MATLAB stores matrices somehow if they were one big vector. Okay, so that's why we have single digit indexing, single indexing. So how do you create arrays? Well, we use these square brackets. For example, x equals open square bracket 1, 2, 3 closed, and here put a semicolon to suppress the output. These comments here, they're actually optional. You could put a space instead. If you want to concatenate arrays, well, if you want to put one next to the other, we use a comma, and one below the other, we use the semicolon. Okay? How do we index them? So when we say indexing, we mean how do you refer to parts of a vector or a matrix? Well, we use not the square brackets, but the parentheses. Okay? And we usually give first the number of the row or rows that interest us, and second the number of the column or columns that we want. We looked at basic operators. I think these are clear so far. And how do you define a range? Well, you put, for example, 1:10 would take all the numbers increasing by 1 from 1 to 10. If you put 1 colon, which means 10, it goes from 1 to 10 in steps of 2. So 1, 3, 5, etc. And just to see if you are awake, so let's create, you don't have to type this, yeah? Let's just imagine we create x equals all the vectors from 1 to 5. And now I want to switch the first and the last. One way to do this is first to index the first and the last. So indexing is with these parentheses, yeah? But now I'm using, inside of this parenthesis, I'm using the, if you want, the single digit indexing. So I'm taking the first and the fifth, yeah? and assign to them the reverse, 5 and 1. So that's what it does. Is that clear for everybody? Yeah. And in 3D, if I create a 3D matrix, so first I create y, then I concatenate y into the third dimension. So now I'm using the function cat. I'm going into the third dimension, so that means adding pages one after the other. And what am I adding? Y. Okay? So now, oh, that's another way to do it. And then if I type size of y now, I get 3 numbers. It was 3 rows by 3 columns before, but now it also has 2 pages. So the last dimension is 2. And if I want to change the first element in the second page, I can do it like that. So first I indicate the first row, first column, second page, and then I assign something to it. Assign 33. So here I'm just, I'm assigning 33 to it, and so now I'm looking at the first page, and now I'm looking at the second page, and indeed there's 33 in it. Before they were the same, so there was 8 here and 8 here, and now I've changed it to 33. And you can also switch elements, for example, again by calling element 1 and 10. So element 1 is clear to everybody, right? It's this one. But then imagine you go down the columns, 1, 2, 3, 4, 5, 6, 7, 8, 9. Element 10 is actually the first row and first column of the second page. This is page 1, this is page 2. Yeah? So if I index elements 1 and 10, and I say I want the 8 and the 33, and assign to them the reverse. So now the 33 is going to go here, and the 8 is going to go here. And I don't have space to show it, because now we're going to move on to, unless you have questions. Do you have any questions to what I presented here? Is this clear? Yeah? Okay. So then let's see what we're going to talk about today. A lot of stuff to cover. Let's see how far we get. We're going to talk about reshaping matrices, what the array editor actually does, some arithmetic operations, how to modify the search path, how to save and load some data, what logical operators are and how you can use them. And then we're going to look into the statistics toolbox. And I mean, some of this might be a little bit advanced for some of you, but we're only quickly going to show you how you can explore your data with some Boxplots, check normality, do some correlations, t-tests, etc. And if you get to it, ANOVA and bootstrap. Yeah? Okay. So, if you have a matrix X, which has 2 rows and 2 columns, we can turn it by simply adding this little apostrophe. Yeah? So X prime is actually X turned around. It's a shortcut for the function transpose. We can also use other functions which are flip, up, down. So now, what used to be, so flip up, down, I'm flipping this one, right? So what is the first row becomes the last row, what is the last row becomes the first. Flip left, right. Well, it's the same thing, only the first column becomes the last column, and the second column the first. So reverse the order of each. That should be a column. And then there's another function which is rotate 90, you can try it out later, which rotates by 90 degrees. If you type, and this is always true, if you type the function name wrongly, so for example, this function doesn't exist, flip up, unless you create it and call it like this. So if you try to call flip up down and misspell it, you get an error, obvious, right? And this, I also said already, if you refer to an element or range outside the boundaries of a vector matrix, you also get an error. We talked about this another. Okay, what's the array editor? Well, you might already have found out that when you double click on a variable which you created and which is in your workspace, a new thing opens up, which is the variable editor. However, maybe you haven't realized that you can go and modify in real time numbers in there, like if it were an Excel sheet. Okay. So here we have on the second row, for example, I have 9, 10, 11, and I can say I change the 10 into a 5, and it will in real time change it, and my variable x will be changed. You can also copy that stuff and paste it into Excel or a text file or Word or whatever, or the other way around. You can take something from Excel and paste it in there. So that's an easy way to interact in a way which is user-friendly with data. Yeah. Oh, and if you change your x variable by modifying it with code, it will also change automatically in here. This is, for example, not the case in R, if you guys use R. Oh, and just one caveat. So if you have very large variables, like later on maybe you have fMRI or ET data, heavy matrices, don't try to open them in the array editor because it will explode Matlab. Good. So vectorization of operations in Matlab works like this. Most common functions are vectorized, which means that they will be applied to every element of the array. Okay. For example, if I have a vector with 4 numbers, vector 4, and it contains positive and negative numbers, and I apply the function abs to it, so it takes only the positive number, puts everything into positive. It applies it to every single element in X. Yeah? And here are some other examples for it. You can also, like this, you can work with adding or removing numbers to every element in a vector or matrix. For example, here I have the vector z, which contains numbers from 1 to 6 arranged in a 2 rows by 3 columns matrix. Now I say z plus 100, and automatically 100 is added to every single element. Okay, so that's pretty handy. You can also subtract, and you can also add 2 vectors or matrices of the same size to each other. So if I have x 1, 2, 3, 4, it's a matrix of 2 by 2, and y has the same dimension. And I can say x plus y, and it will automatically take the sum. Here will be 1 and 6 is 7, 2 and 7 is 9, 3 and 8 is 11, etc. So it adds each element with the same element in the same position in the other matrix. However, you need to be careful. So this works very well for plus and minus, for adding and subtracting. But when you want to multiply or divide, you need to be careful, because there's something which is called matrix multiplication, which uses the multiplication sign, but works not as you would expect. Okay? So for example, if you have a 2 by 2 matrix, as we said here, the result would be completely different, and you can try it out later. It would multiply x1 with y1, add the multiplication of x3 times y2, etc. So it gives you other numbers, and it has a meaning, a mathematical meaning, but depending on what work you do, that's not what you want to do. That's most of the time you want to use something else, which is the element-wise operation. So again, this is what you don't want to do. You don't want to multiply x times y like this, but you want to add a little dot before the multiplication sign. Okay? So now we get what we want. We get 1 is multiplied with 6 equals to 6. 2 is multiplied with 7 equals 14, etc. That's what, for example, in most of the cases I'm interested in. To have that, you need to add a little dot before the multiplication. Same thing if you divide. You need to add a little dot before yeah, that's what I just said. Also with power, the power sign, same thing. Huh? However, with plus and minus, you don't need to worry. You can add a dot or not, it's going to be the same. Okay, another thing to know is that many operations you apply to matrices, they first go down each column, so in the first dimension. And if you want to apply them to the second dimension, you have to say it specifically. So if I have here a matrix 2 by 2, and I say sum of x, what it's going to do is that it's going to sum the elements of both rows for each column separately. So 3 and 1 is going to be 4, that's the sum of the first column. And 2 and 4 is 6, that's the sum of the second column. So your result are two numbers, okay? And if I want to do the sum to the other direction, I need to say sum x, comma, 2. So you can indicate the dimension you want to go with, the direction you want to go with. Same applies to max. I want to know the max of each column, I just say max. If I want to know the max of each row, I need to say max, comma, 2. Ciao. Oh, he had some questions. How would you compute the mean, for example? How would you make the sum along the lines? I just told you. So you just add comma 2. You can maybe try this out later. The mean, you'll see how you do it. There's a function, for example, called mean, which is the easiest way. Oh, yes, here it is. For example, if you just say mean of x, you get again two numbers because it goes down in the first dimension. Yeah, you can look at this later on. Okay, questions? No questions? What did I do? Okay, so Matlab, if you want to use stuff which data or functions which you have somewhere, you need to tell Matlab where to look at. And usually Matlab will search files in the current directory and in the Matlab directory and in all folders which you have defined and giving him in the thing which is called the search path. So this I already told you. You can see where you are currently in the working directory. And you can see the contents of it using dir or ls. And search path is a subset of all folders, as I said, which Matlab looks into. So you'll have to specify in the beginning of each session, please use this folder here with some functions and this folder here with some data. You can sort of set up your search path and save it, and every time you open up Matlab is going to know based on that search path, oh, I need to access this and this folder. So by default, the search path includes those folders provided with Matlab and all the toolboxes. For example, some of the data we already started to play with in the exercise here, we were like, load this and this data, for example, This is data which comes with Matlab, and thanks to the search path, he knows where to look at. So then as a user path, it's when you open up your Matlab, where are you actually, in which directory? And you can add or remove folders and make them available to Matlab. And sometimes when you're on a computer and you don't have all the rights, and this happens sometimes with CISA, it tells you, oh, you cannot save or modify the search path, but you can save it somewhere else, and then tell Matlab to use that. And this is also interesting. If you have, for example, I don't know, you have two folders that contain two different versions of the same function, right? So for some reason you have modified the function, and you have given to the search path both folders. One that contains the original function, one contains the new function. Well, in that case, which one is MATLAB going to use when you call the function? Say the function mean. I have two functions with the same name, but they're slightly different. Yeah. And if I call the function mean in MATLAB, he's going to use the one which is highest in the search path. So if you have redundancy, it takes what is more recent if you want. And you can say also, you can see duplicates of your files in your search path using which and then putting, for example, the name of the function or toolbox. How do you modify the search path? This is a little bit older version, I guess 2012. So you need to go on set path. And if you don't have it open now, we can look at it later. And then you can, there's a button that says add folder or add with subfolders. Most of the time you want to add with subfolders. And then you save it, you look for your folder of interest and then you save it and close it. And that's it. If you want to see the contents of your path, it's probably going to be easier. You just type in the command window, you type path, right? And it should give you a long list of everything that is inside. If you want to change the contents, yeah, you do this with the graphical user interface. You have to know that the path is saved in something which is called pathdef.m. So that's the thing which is basically a text file containing the list of folders and files MATLAB needs to remember. And per default, it should be in MATLAB root /toolbox/local. You can move it somewhere else, it doesn't matter. So you can save changes to the path using the function save path. Or the save button up here, which is the easiest thing. And this will update pathdef. Okay. So, once we have created our variables and done our analysis, we want to save some stuff also in MATLAB. Now I'm showing you just how you save data in the .mat format, which is MATLAB's format. Obviously, you can save in many different formats. For example, if you create variables x and y, you can say there's two similar versions to save them. You can either type save space the name you want to give it, for example, day2 dot mat, and then you indicate the variables you want to save, x and y, or you do it like this, okay? And if you use the parentheses, you need to put some quotes. You can also save only x if you want. You don't have to say x and y. And here I said that there's another way to do this, which is the variables x and y are going to be in your workspace, right? So you can just go on top of it, do a right click, and then save, and it even gives you the option of saving it in different versions, in different formats. How do you now load data? Well, we already saw, I think on Monday we already asked you to say, type load space and then some name. These were data sets which come with MATLAB. Usually you have to say load some data.mat, and you can also only load, for example, if test.mat contains x and y, you could only load x, say. Or you could load everything which is in test.mat. Again, also here, in the current folder window, you see all the files you have in that folder, and if there is a test.mat which appears, you can double click it and it will load it. Easy. Third way to import the data is using the graphical user interface and the option import data. So what you should get is something like this, and this gives you a lot of options and gives you a preview of the data that you're trying to load. Here, for example, I was loading a matrix which contains numbers and strings and has a header line, and you can load it as vectors, column vectors, as a numeric matrix, cell array, table. These are different formats. Here I was loading it as a table. As you can see, this is great. And with the option replace unimportable cells with not a number, NaN. It shows you, this cell I cannot import it, I'm going to put NaN. And depending on what you choose, for example, if you choose numeric matrix, he's only going to import what he can, which is going to be this and this and this without the header. Okay, so you can play around with this actually to get a feel of what is numeric data, what is not, what are these different array types. Cell array can take everything, for example. Good. Questions? No? If you have questions, don't hesitate. Now we're going to talk about logical operators, which are also very important. And basically you have equality. So you want to know if A equals B. And to test this, we put not one equal sign, but two. You remember that to create a variable and assign something to it, we use one equal sign. But to test if two variables are the same, we use two equal signs. Yeah? Different is equal with a little tilde. In Spanish it's a tilde in front. I don't even know the English word for that. Anybody knows?
I think it's tilde.
It's tilde, okay. Then we have, okay, obviously you have bigger, smaller, smaller equal, bigger equal to. Negation, so something which is not something else. You have and, so both, for example, A and B means that both A and B are true. We have or, which means either A or B or both are true. And you need to know that negation, the and the or, they only operate on logical operands. You cannot use them on numbers. And if one set is a scalar, yes, if both sides are matrices, they should be of the same size. That's important. So let's see some examples. You should know that false is typically indicated as 0 and true as 1. So if we have a vector A which contains numbers 1, 5, 3, 4, 8, 3, and we want to create now a second vector which contains only the number that tells me where A is bigger than 2. So I say B equals A bigger than 2, and that's the output here. B is going to have the same size as A, and it's going to have zeros and ones, and it's going to be a logical vector. I can also create C, which that tells me where A is smaller than 5. So C equals 1 here because 1 is smaller than 5. 0 here because it's not true that 5 is smaller than 5. Clear? And I can combine them. So I can say, let's create D, which indicates to me which element of A is both bigger than 2 and smaller than 5. So that's what I'm doing here. And only 3, 4, and 3 are smaller than 5 and bigger than 2. So we have 3 ones. As I said, this is D, C, and B. They are logical arrays. Okay? They're not doubles, for example. They're not numbers in the common sense. If you type whos of D, you get a description of it. Logical operators also work between two arrays. For example, if you have A and B, which contain numbers, and you want to say, show me where A is bigger than B. He also can show you, he creates a new logical vector which has the same numbers of elements as A, and shows you where A is bigger than B. Okay. A logical can be used instead of an index if it matches with the size. So let's create x, has 4 numbers, and now we want the second and fourth element, and we can either say, we index them like that, or we can say, let's create a new vector and say put 0 for the element we don't want and 1 for the element we want. So now that this is clear, this is basically the same. You can use logical operators and logical indexing to extract elements out of a vector matrix that correspond to something you're interested in. For example, you could extract elements which are less than 3. So x smaller than 3, well, only 4 gives us 100 because x equals 0, 1. Well, I'm not sure about that. I have to verify. X smaller than 3. Oh, sorry, because x is no longer this. X is this one. And so 1 is smaller than 3, while 0 doesn't count. And so it takes elements. No, that's not true. Oh, okay, now I got you. So, I have x here, and now I'm using, there's a little mix up with names, but basically I'm using a logical operator inside of a logical operator. In a logical operator, I want to look at x is this one, where x is smaller than 3. Using this one. And there has been a mix-up and it's not well written, but that's basically the idea. So if I take these two elements, I use them to actually select from here. That's what this wants to say. Sorry for the mess. Oh, Carlotta, you have to delete this passage after. Okay, so then you have the function find. So you can use, for example, find to find all the elements which are not 0 in x. Or it gives you the positions of the elements which are not 0. And what is this again? Find x smaller than 2. 2 and 5. Yes. Okay. So I could, if I want to know which elements of x are smaller than 2, I say find, open parentheses, x smaller than 2, and I get the second and the fifth position are the ones which correspond to this condition. Okay. So this was a little bit messy, but did you get the main idea?
I didn't get why doesn't 0 count here? Elements 1, 2, 3, and 5 are smaller than 2. Because find only gives the non-zero values. Is that why?
Yeah, exactly. No, wait. If you use just find, you find non-zero values, and if you say find of x more than 2, you're right. I would also expect 0 to come out. Can you just try it out? Or can you do it? If you don't know how to do something, just try it out and.
No, it gives the zeros also.
It gives the zeros. So then I need to change my slide. Yeah. More to cut out. Find
You focus next time.
x smaller.
Smaller.
Yeah.
No, it didn't. Yeah, sorry. I thought these were the indexes. No, it didn't. Yeah.
Sorry, I have a problem with the mouse. So the elements are 0, 1, 4, 3, and yes, it takes also the 0, but it gives me the indexes of the 0.
It gives the indexes.
Yeah, and the example I
number.
gave before. Okay, let's see if I can put it back. It should give us the index 1, 2, 3, and 5, and so this is indeed wrong. Okay. Good. Okay, so more questions? No? Okay. Then I'm going to talk about the statistics toolbox, which is actually a very important toolbox, and we only have 15 minutes to go through it. Obviously, you're going to have a lot of questions, but at least you're going to have an idea of what you can do with it. So, some of the functions with which you can do statistics are in the so-called core Matlab. For example, the functions max, mean, median, min, standard deviation, sum, variance. But for others, you require a statistics toolbox, and some are very important. For example, if you want to do a correlation or a t-test or an ANOVA, these kind of things, and much more. And you can do very nice plotting with the statistics toolbox, like Boxplots, non-plots, and you're going to see now how this works. For example, here I loaded the built-in data car small, and I put miles per gallon and the acceleration and concatenated them. These are two, I guess, columns which come with car small. And then I just did Boxplot of matrix, and what I get is, and I get the acceleration, and so I get these two variables. So it's very small even for me. I get the two variables, miles per gallon and acceleration. I get the mean, and per default, it's probably going to, so it's the mean, sorry, the median. Per default, you can modify these parameters in the Boxplot. And these edges here of the box are the 25th and 77th percentiles, so how much of the data is contained in this range. And then you have the extreme data points, for example, this dot here. Okay, you can also, so this is the function Boxplot and just give something, but there's also a function where you have a grouping variable. So that's what I'm doing here. So here, from this car small, I'm doing Boxplot, miles per gallon, against the grouping variable origin. And here I have basically the median and these percentiles of the mile per gallon variable across 5 or 6 origins of cars. So these are American cars, and then I don't see it, but you know there's France and Japan, etc. So this is really a handy idea to get a first visual impression of how's my data actually looking. And another thing which is important is the distribution of your data. So you could just do a histogram, for example, with histfit, and then you put in the variable. And so in blue, you see the number of values that correspond, the number of times a certain value comes up. So say this is mile per gallon 50. Well, there's maybe 20 cars who have this mile per gallon value. And there's more cars who have 45 and 55. Okay? Well, a normal distribution, you probably know, has this Gaussian shape, which is represented by this red line. And you just want to get a first visual impression, is my data more or less normally distributed or is it not? This is not very good, but this is not horrible. You can also change the size of these containers, of these bins, by adding a number here. And so now I have smaller windows. Another way to check the normality is with norm plot. Values which are normally distributed, so which follow this Gaussian curve, they should be gathered along the diagonal line here in red. And if they depart from it too much, especially in the beginning and the end, well, it suggests that it's not normally distributed. They also test to actually see if the data is normally distributed. No way, none of these methods is perfect. And there's also some robustness in the fact that some of the statistical tests I'm showing you now, they basically want the data to be normally distributed. But if the data is not exactly normally distributed, it's not that bad. Let's say like this. So that means the test is a little bit robust for violations of normal distribution. Okay. We have 10 minutes. Maybe we can do this all together if you have Matlab open. You just type load exam grades. And you get, if I remember well, it's a matrix of 120 lines times 5 columns. Let's suppose that these are 120 students and they passed 5 different exams. Did you open? Yeah? So now if you want to correlate these 5 exams, you just type core grades. Because grades is the matrix, right, that opened up. That's the name of the matrix. And so what do you get? A correlation matrix which has as many rows as it has columns because you have 5 columns. And the diagonal line is the correlation with itself. So for example, the first column correlated with itself is a perfect correlation, obviously. The first column correlated with the second column is still a very high correlation. So these are the Pearson correlation, the R's, the correlation values. You can also compute a non-parametric Spearman correlation to get the row and p-values if you're interested in. So before this core, you can add, actually, there's some functions in Matlab where you can increase the output, and the way you do it is you specify it with these brackets. If you go later on and type help core, it will probably tell you this option. So now I tell it I want not only the correlational value, but also the p-value. There are 2 different outputs. And the type, I don't want it to be Pearson, I want it to be Spearman. So this is somewhat better because it sort of ranks the data. So especially if it's not normally distributed, it's somewhat better. And so here, I mean, you can see that they're all highly significant, these correlations. They all have a p-value which is so small that it seems to be 0.
Why is the p-value 1 in the diagonal? It should be 0.
Why is the p-value 1? I don't know. No. But that is not important, so that's not what you should look at. But it's a good question. Let's find out in the head. Okay, there's a really cool plotting function here called core plot. So you can try that out. It gives you something very similar, only in a visual way. So it also shows you the distribution of each column. So you have the 5 columns, and it shows you how the scatter plot looks when you correlate the first and the second here, or the first and the third, etc. On top of that, it puts a regression line, and it should also give you So small. But maybe if you do it, you can see better. It should give you probably the correlation value. And it may be, or that's an option that we'll show you later on. There isn't a way to change the color whether it's significant or not. So that's really, really handy. Does it work? Yes? Okay. Okay, you guys know what a t-test is? Yeah? Yes? No? You don't know? Okay. So you can do it for different reasons. For example, let's say you have a range of values. I take your age, okay, and it's going to have a mean of say 27 and a certain standard deviation, and I take another class's age and standard deviation, and then I want to compare and see if you guys are significantly younger than the other ones, or older, or whatever, just different age. So let's say they have a mean, in the next class they have a mean age of 30, okay, that's a different age, but is it significantly different? Well, one way of doing it is a t-test. And actually I gave the wrong example, because here I'm explaining it in a paired sample t-test, while I just introduced the independent sample t-test. The paired sample t-test would be, today I measure how much you know about Matlab with an exam, and tomorrow you come in, do the same exam again, so that's the same sample twice, and then I compare, you know, did you get better? Yes, but how much better? Did you get significantly better on the second day? So that's, you can use the t-test, paired sample t-test in this case, to compare these kind of things. And so what you do is you try to reject the hypothesis 0, the null hypothesis, that two sets of data. Oh, and here I gave an example for the subjects. You know, that two subjects which were tested twice, like you guys in Matlab, they come from the same distribution. And if the t-test is significant, you reject the null hypothesis. And so, still with this exam grades, we could say, for example, that the first and second column, what I'm doing here, I'm indexing the matrix grades, right? Indexing with parentheses. You guys should now notice, whenever you see the name of a variable and open parentheses, it thinks, he's calling elements of that variable. So I'm calling all the rows of the first and second column, right? And let's say these represent the same students, so you guys, in two different exams. And let's also say that the data is normally distributed. Okay. So I'm going to use this paired sample t-test to ask if there's a difference, significant difference between the two exams, and that's the formula. So the function is t-test, and here I'm increasing the outputs I'm getting to get some more statistics, confidence intervals, and p-values. And these are just the two columns of the matrix I'm comparing. So the outputs I get are first this h value, which I've never heard of. Maybe it's a Matlab thing.
Just 0 and 1.
Yeah, it's a Matlab thing, I guess. Which tells you if it's significant or not. And if h is 0, the test is not significant. It gets you the p-value, which is the more common one. And you know that usually we look for p-values smaller than p05 in psychology. I don't know how it is in the specific domains you work in. Maybe in genomics it's different. No? No? Same? p05? You know? You guys in genomics?
No.
Ah, sorry. You are in neurobiology. So there, for example, if you comparing the number of bacteria in two petri dishes, to one you spit in and the other one you pee in, you want to know how sure do you want to be that there's a difference in the number of bacteria. Do you want to have a 5% chance of being wrong in your answer, or you want to be even more sure, then you're maybe going to go to p.01. I know in medicine they use smaller p-values to be sort of more precise, more sure.
Yeah, but the most common one is 0.5.
Exactly. Yeah. So this means that if you did everything right, you still have a 5% chance of being wrong. Okay? You're never 100% sure. The confidence interval is sort of taking into account the spread of the data. I don't know if I said this right, but let's just think about this. If it crosses 0, it means it's not significant. And this is just a t-value, which also follows a curve. Usually you want it to be smaller than 2, otherwise it's bigger than 2, otherwise it's not significant. The degrees of freedom, you have 120, but you lose 1 for the test. Okay, so I did this test and there's no difference. You guys, tomorrow you will know just as much in Matlab as you know today, unfortunately. But now you know something about, for example, t-test. Okay, so I'm going to go 3 more minutes and then stop. Yeah? And ANOVA, you would use it when you want to compare more than 2 things, for example. Yeah, so let's say instead of giving the same exam to you twice, I do it 3 times in a row. Yeah? So I want to know, is there any change not only from one exam to the next, but across the 3 exams? Maybe you don't learn enough between today and tomorrow, but maybe next week you had time to go through the slides this weekend, and next week, you know, it will be amazing again. Okay, so then I would use an ANOVA, and here you get basically how to do it. What you get out of it is an ANOVA table, and again you get p-values, and you get an f instead of a t-statistics. We get the degrees of freedoms. You usually have to show 2 degrees of freedoms of your tests and of the error. And if you're interested, you can look at it at home. There's a little bit more complex thing, which is a 2-way ANOVA, and there's more ways of doing ANOVA. But just in a nutshell, what is a 2-way ANOVA good for? Well, let's suppose that not only am I comparing you guys across the same exam 3 times, so the same matrix exam but 3 times, but on top of that I introduce another factor, which is either you get to drink coffee in the morning or you don't. Okay? So I can expect that, you know, both factors are somehow important and both are somehow maybe interacting with each other. So you might learn MATLAB, and so in the 3rd exam you're better than in the 1st, but on top of that it's important whether you got coffee or not. So that's why we would use 2-way ANOVA, for example. And again, you can find a lot of help in MATLAB. And we have one more slide, but I think I will keep it for next time, about bootstrapping. And that should be it. Yeah. Okay. Are you guys happy? Do you have any questions? No? Okay, so let's do 5. Sorry, yeah?
If you have a one-way ANOVA with 2 columns, the same as the t-test?
Yes.
Oh, okay, so the same parameters,
yeah.
You can compare them.
Yeah.
Okay.
Well, in one case you get a t, in one case you get an f value.
But it's totally different.
I would say I'm 90% sure it's the same. But I'm not a statistician, so my approach would just be, let's do them and compare them.
ANOVA works the same for the and the formula is the same too. If you have 2 groups, it's just and the value, f value is just t value to the power 2.
Yeah, no, because then it gets a little bit more complicated.
Because one-way ANOVA for 2 groups is just like a t test.
One-way ANOVA,
yeah.
Yeah, but 2-way ANOVA is different. Yeah. Okay. Yeah. I didn't show, but obviously, the kind of example I introduced was for repeated measures, but maybe on the slides I only had between subjects. Yeah. No, absolutely, it's possible. Yeah. Okay, so I would say we do a couple of minutes of break, and then you come back with coffee if you take it usually, and then we do exercises. Yeah.